Before knowing about zeros of polynomial, let us know what does zero mean. Let f of x equals to 2x square plus x minus 6. Zero of f of x. That means values for which f of x is 0. Then it's called as zero of the polynomial. Here let x equals to minus 2. Then f of minus 2 becomes place minus 2 in place of x. 2 into minus 2 whole square plus minus 2 minus 6. That is equals to 2 into 4 minus 2 minus 6. That equals to 8 minus 8 is 0. So, minus 2 is 0 of f of x. This is meaning. And let's see what is the graphical meaning. In graph, what does it mean? So this is the graph of 2x square plus x minus 6. So zeros is nothing but the graph where it touches x-axis. Like the points where y equals to 0 are the zeros of f of x. So here there are two zeros for this, minus 2 comma 0 and 1.5 comma 0. And this is the graphical meaning of a zero for a polynomial. And for a bonus tip, let's see, we have one more meaning from factor theorem. If f of a equals to 0, then f of x is divided by x minus a, right? According to factor theorem. F of minus 2 is 0. So x of x minus 2, that is x plus 2 is the divisor of f of x. And let's see the zeros of polynomial. First degree, linear polynomial or degree 1 polynomial. Let's see about. So the general form of linear polynomial will be like y equals to ax plus b. First degree, right? One term should be x and one term should be constant. So solving this polynomial ax plus b is equals to 0, x equals to minus b by a. That is equals to minus constant by minus coefficient of each. So the zero of this linear polynomial is x, that is equals to minus b by a. Let's see an example. 2x plus 3 equals to 0. Solve for x. We get 2x equals to minus 3, x equals to minus 3 by 2. So the zero of the polynomial 2x plus 3 is minus 3 by 2. Let's see the graphical meaning of linear polynomials. Here x plus 2 touches x-axis at minus 5, 0.5, comma 0. And this line touches at 1.6667, comma 0. So these are the zeros of polynomial. You can see that a linear polynomial is always a straight line. And let's have some lines at random on the graph. Uh, like this and like this, we can see that the maximum number of points it can touch x-axis is 1. So the maximum number of zeros is 1. And quadratic polynomial or degree 2 polynomial. Let's see about this. The basic general form of quadratic polynomial is f of x equals to ax square plus bx plus c. Because the highest degree is 2, it's x squared. Let's see an example. The graph below down one has two zeros because it's touching x-axis at 2 points. So it has two zeros, and the graph above it has no zeros because it's not touching x-axis. Quadratic polynomial is always a parabola. Let's see some more examples. Like graphs are drawn at random, parabolas are drawn at random. You can see the maximum number of zeros is 2 because 2, 1, 2, and last one has no zeros. So the maximum number of zeros a parabola like a quadratic polynomial can have is 2. So let all zeros be alpha and beta. Then the relationship between zeros and the coefficient of the polynomial is alpha plus beta equals to minus b by a, that equals to minus coefficient of x by coefficient of x square. Alpha into beta is equals to c by a, that is equals to constant by coefficient of x square. You need to remember this. These are very important. And some may have doubt like 2x square plus 7 graph has no zeros, right? Why can't we solve that? Why can't does have zeros? Okay, let's see about that. Let's take that equation. 2x square plus 7 equals to 0. Let's solve this. If 2x square minus 7 becomes this side, it's become minus 1. X square equals to minus 7 by 2. X equals to plus or minus roots minus 7 by 2. You can say that it has two zeros. The graph is wrong. But no, this is wrong because plus or minus under root minus 1 into root 7 by 2. Plus or root minus 1 is I. It becomes plus or minus I root 7 by 2. I is an imaginary number, so this is not a real number. So these are not real zeros, these are imaginary zeros. Numbers can't be displayed in graphs, so this is correct. It has no real zeros. And now let's discuss about cubic polynomial or degree 3 polynomial. So the basic general form of cubic polynomial is ax cubed plus bx squared plus cx plus d. And let's see an example here. X-axis is touched three times, so it has three zeros. And let's see some more examples. In the first graph, it's touching 3 points, so three zeros. In second graph, it's touching 1.10. Here it's touching 2 points, two zeros. The maximum number of zeros for cubic is 3 because it can't be more than 3. It's 0, 1, or 2, or 3. And if alpha, beta, and gamma are the zeros of the cubic polynomial, then the relationship is alpha plus beta plus gamma equals to minus b by a, that is equals to minus coefficient of x square by coefficient of x cube. Alpha beta plus beta gamma plus alpha gamma is equals to c by a, that is coefficient of x by coefficient of x cube. Alpha beta gamma is equals to minus d by a, that is equals to minus constant by coefficient of x cube. You can see the pattern here, minus b by a, c by a, and minus d by a. Remember these are very important for cubic polynomial. Now let's discuss about nth degree polynomial. Let's see what we have discussed till now. Maximum number of zeros for a linear polynomial is 1. For quadratic, it's 2. For cubic, it's 3. The degrees of these polynomials are 1, 2, and 3. So for nth degree polynomial, the maximum number of zeros is n. Thank you.